Imagine for a moment that you're falling into a black hole. Welcome to this explainer, everyone. I am absolutely thrilled you're joining me today because we are about to plunge feet first into one of the most extreme, mind-bending thought experiments in the cosmos. We're going to explore what is arguably the most terrifying, yet utterly fascinating demise in the universe. Get ready, because reality is about to get incredibly weird. At first, honestly, the free fall feels perfectly normal. You're just floating. There's no physical wall you crash into, no warning signs, absolutely no bumps in the road. You're just moving forward through space. But then, something deeply unsettling starts to happen. Because you're falling feet first, your feet are just slightly closer to the center of the black hole than your head is. And suddenly, your legs start accelerating much, much faster than your upper body. Your body begins to stretch out vertically, while at the exact same time, you're being compressed horizontally from the sides. Your bones stretch out, your organs completely deform, and eventually you are drawn out into a long, incredibly thin thread of matter. Physicists actually have an official and frankly bizarre term for this. They call it spaghettification. And listen, this isn't science fiction. This is very real physics, a direct mathematical consequence of Albert Einstein's general theory of relativity. Section 1. Gravity and tidal forces. So what actually causes this horrifying cosmic stretch? Well, first let's establish what we're falling into. A black hole is a region of space where gravity is so impossibly strong that absolutely nothing, not even light, can escape its boundary, which we call the event horizon. Once you cross that line, return is impossible. But we need to clear up a massive misconception right off the bat. People usually think black holes act like giant space vacuums that aggressively suck you in. That's a myth. The physical reality is entirely different. The true danger doesn't come from the total pull of gravity, but from the extreme difference in gravitational pull across a distance. Astrophysicist Neil deGrasse Tyson sums it up perfectly. He says, "The difference in the force between your feet and the top of your head gets greater and greater." You see, as you approach the incredibly compact, incredibly dense center of a black hole, your height, say 5 or 6 feet, suddenly becomes a really significant fraction of your total distance to that center. Because of that, the difference in gravity, which physicists call the tidal force, becomes completely unrelenting. To put that into everyday terms, here on Earth, the human body can normally only survive an acceleration of about 9 Gs. That's 9 times Earth's gravity before experiencing severe, life-threatening trauma. But near a black hole, that limit is obliterated in a fraction of a second. The tidal forces skyrocket to millions, then billions of Gs. Our bodies simply aren't built to handle gravity behaving like this. Section 2, becoming cosmic spaghetti. So what does this actually look like for our unlucky astronaut? Let's walk through the visceral, step-by-step reality here. First, the tidal force becomes so immense that it simply exceeds the molecular bonds holding your flesh together. Your bones, your muscles, your blood vessels, they all just fail. You don't stretch like a rubber band forever. Eventually, you snap. Initially, you'd likely snap into 2 pieces right at the lower spine. Then those 2 pieces feel the exact same force and snap again, maybe at the base of the neck. You subdivide into 4, then 8, 16, 32 pieces, exponentially snapping until you're nothing but a single-file stream of disconnected atoms pouring down into the void. You are quite literally being extruded through the fabric of space and time, funneled inward, almost like toothpaste being aggressively squeezed from a tube. Now, I know this sounds incredibly agonizing, but the one tiny bit of good news here? This process, this final destruction, happens incredibly fast, way quicker than your brain's pain receptors could ever even process. Section 3, does black hole size matter? Okay, here's where we get to subvert your expectations a bit. A really unexpected fact is that not all black holes will spaghettify you immediately. The size of the black hole drastically changes your experience. If you fall into a stellar mass black hole, one that's maybe 10 to 60 times the mass of our sun, the tidal forces are already extreme right at the event horizon. You're torn apart before you even cross the threshold. But with supermassive black holes, the story is totally different. Because they are so unbelievably vast, the distance from the edge to the center is enormous. That means the tidal forces at the event horizon are actually negligible. You could literally cross the point of no return completely unharmed. Take Sagittarius A star, for example, the supermassive black hole at the center of our very own Milky Way galaxy. Recent physics research calculated the critical mass you'd need to survive a plunge along a rotating black hole's axis.
That threshold is about 900 solar masses. Well, Sagittarius A star is over 4 million solar masses, so it is thousands of times larger than the critical threshold needed to survive the initial drop.
And it gets even wilder. Consider a titan like the supermassive black hole TON 618. Its diameter is a mind-boggling 180 billion kilometers. To put that in perspective, that's 40 times the distance from our sun to Neptune. In a black hole that big, you could theoretically free-fall past the event horizon and live out the rest of your entire natural lifespan inside the black hole before you ever got close enough to the center to actually be spaghettified. But remember, thanks to relativity, your perspective isn't the only one out there. If someone were watching you fall from a safe distance, they'd see a really strange picture. To an outside observer, you never actually seem to cross the horizon. As you get closer, your image seems to slow down. The light from you stretches and gets redder until you appear to just freeze in place and slowly fade away. But for you, the traveler, like we said earlier, there's no wall, no bump, just a continuous, seamless falling into the dark.
Section 4. The inevitable end.
Because look, whether it takes a millisecond or a lifetime, if you are falling inward, you must eventually approach the center. And modern physics tells us what awaits you there. Inside a rotating black hole, you'd encounter an invisible wall of sheer, destructive energy. This is due to a phenomenon called mass inflation. Basically, radiation falling in interacts with radiation trying to bounce out, creating an extreme feedback loop where the internal gravitational mass and the tidal forces skyrocket toward infinity. And hey, that's assuming you manage to avoid the other completely lethal hazards. We're talking extreme heat from the accretion disk, relativistic jets of energy shooting out from the poles, and even the wild hypothetical risk of microscopic primordial black holes. Imagine colliding with something the size of an atom, but with the mass of an asteroid. It would blast right through you, emitting a lethal supersonic shockwave. So the ultimate reality is this: survival at the very center is impossible. General relativity, exactly as Einstein predicted, dictates that near the singularity, gravity reaches infinity. There is no known material, no futuristic armor, no advanced technology that can withstand the extreme tidal forces waiting at the bottom. Every single atom that makes up your body will eventually and inevitably be torn apart. A black hole doesn't just swallow matter, it completely changes the very structure of space and time. Which leaves us with one profound mystery. If a black hole completely destroys your physical structure, breaking you down past the atomic level into cosmic spaghetti, where does the quantum information of you actually go? Does it vanish, violating the laws of quantum mechanics, or is it somehow preserved in the cosmos? If you're fascinated by black holes, by space, and by just how strangely wonderful the reality of our universe really is, make sure to subscribe to Code of the Universe. We're going to keep showing you just how amazing reality can be. Keep looking up and stay curious.